like if one vertex is inside and another is outside, then what? So if this is the case, then what it says, only the edge intersection with the window boundary is added to the output vertex list. Okay, so as you can see, this intersection point will only be added in this case. Okay, if it is from inside to outside. Similarly, both are outside, then you don't have to any, like you don't need to add anything to the output list. Similarly, if it is from outside to inside, then both of this thing is to be added. Both, if I say, then the intersection point as well as this point. Okay, that is the second vertex. So based on this principle, we have seen this example. And yeah, so we out like try to follow that principles only. So if your line is out, if both of the points are outside, then what? So you do not have to add anything, but obviously we will start from the points that are given to us, that is 1 2 3 4 5 and 6. As you can see, the same thing we have already seen. This is just an like overview so that we can go with our next algorithm. Okay, so now based on that, we try to like get the output points. So but obviously we'll take one condition, one case over here, that is this line that is from 2 to 3. As you can see, it is going like from outside to inside. Okay, so this is the case from outside to inside. Then what? So if we move to vertex 3, which is inside, we calculate the intersection point, and at both intersection point and vertex 3 to the output list. As it is like written over here, we have given it one name, that is 1 dash. 1 dash is nothing but our intersection point. Similarly, the next point that we will add is 2 dash, that is the another point, that is the second vertex that we have, and we will add it to our output list. So we have to like similarly follow this thing. If both the things are inside, if both the points are inside, then what? Then we have to just add the second vertex as it is in this particular thing. As you can see, then we move to vertex 4, in which vertex 3 and 4 both are inside. Then we just add one vertex, that is 4, to the output list. You name it as 3 dash. Okay, similar thing is to be followed, and similarly for 4 to 5, and yeah, similarly for like 4 to 5 and so on, you have to follow. Okay, and yeah, so these are the things that we have in polygon clipping, and I'm not going to repeat this thing because we have already seen this thing. But one problem that we were facing in the Sutherland-Hodgman algorithm, that it may not be able to clip concave polygon properly. Okay, as I said that in the yesterday's lecture, that you would be getting some sort of this shape where your like clip polygon would be joined. Okay, and you would be getting something like this. So what is the thing is, the ultimate goal is to get the properly clipped part, but now what we are getting is in between line is also getting like displayed. You don't want this condition, so that's why it says that it may not be able to clip it properly. Okay, so what it says is, one thing that you can do is you can like similarly divide the whole of the polygon, the bigger polygon, into multiple things, and that is always the thing that you can do, but it will again requires more time and more efforts to do all of this thing. So instead of that, what it says is we can just use the approach that is known as Euler-Atherton algorithm. Okay, so a very like well-known algorithm we have is the Euler-Atherton polygon clipping. So based on the same conditions, we will try to adapt the same thing that was there in the Sutherland-Hodgman vertex processing algorithm. We will like try to modify the same thing, and we will understand this thing, that is Euler-Atherton polygon clipping. So now what it says, it modifies the Sutherland-Hodgman vertex processing procedure for window boundary so that the concave polygon can also be clipped properly. Okay, so now it says that we will try to just modify the previous algorithm so that we can get a perfect clip polygon or clip shape. Okay, so this can be applied by applied for arbitrary polygon clipping region, as it is developed for visible surface identification. Okay, so now this means that like suppose we have one shape where one thing is hiding another thing. Okay, one like line or one visible thing is there, and one thing is getting hidden to the from the previous thing. So what it says is, this algorithm specifically would be able to display the visible part from the viewer's direction. So that is what we will see, and we'll try to understand it. So now procedure is similar to Sutherland Hodgman algorithm. Okay, only change is, now you try to understand this thing. Only change is sometime it needs to follow the window boundaries instead of always following the polygon boundaries. In the previous case, we always followed the polygon boundaries. Okay, whether your vertex is going from like outside to inside, or whether it is coming from outside, or whatever the condition it may be, we were just following the polygon boundaries. Okay, but now over here we need to modify it a bit so that we can also follow the window boundary to solve the earlier problem that we were getting in the concave polygon. Okay, so now for clockwise passing of polygon vertices, we use the following rule. Okay, so which are the two rules that we have? For an outside to inside pair of vertices, follow the polygon boundary. Now keep this thing in mind. For an outside to inside pair, what you have to do is you have to follow polygon boundary. But if for an inside to outside pair of vertices, follow the window boundary in a clockwise direction. Okay. So now keep two things in your mind. That is, from outside to inside, you have to follow the polygon boundary. But if it is from inside to outside, then you have to follow the window boundary so that this problem would be solved and we can get a proper shape after clipping. Okay, so here is the same example that was there in our like Sutherland Hodgman algorithm, and that was giving us one problem, that it was displaying the line that we don't require. But now this problem would be solved in this Sutherland Hodgman algorithm. Sorry, this Wheeler Atherton algorithm. So now again we will start from the very beginning, very first step. Okay, so now start from V1, as you can see, and move clockwise direction towards V2. Okay, we have to move in this direction and add intersection point and next point to the output list by following polygon boundary. What it says is, if it is from outside to inside, yeah, so first thing is getting satisfied, as you can see. Okay, so if this is the case, then what you have to do is you have to follow the polygon boundary. Okay, and add intersection point and next point to the output list. But obviously, as it is from outside to inside, then you have to add intersection point as well as the second vertex into the output list. Okay, so our new points will be V1 dash, that is the intersection point, and V2 will be our V2 dash, that is the new thing that we got out of the this out of this direction, that is from outside to inside. Okay, then from V2 to V3 we add V3 to the output list. Based on the Sutherland Hodgman algorithm, if both are inside, then what it says is you just have to add the second vertex, okay, into the output list. So that is what we have done. Okay, so we will name it as V3, as you can see in this thing, in this slide, and from V3 to V4. Okay, just go in this direction only. Now we are getting one new thing over here, that it is going outside from inside. Okay, so what if this thing is getting yeah, what if we are getting this kind of situation? So from V3 to V4, what it says, we calculate intersection point and add to output list and follow the window boundary. Okay, but obviously now we are going outside from inside, and if this is the case, then what it says is you just have to add the intersection point only. So वो तो हमको करना ही है, but now this algorithm says that this is the case, then what? So now from inside to outside, as you can see, our second like point is getting satisfied. So follow the window boundary in a clockwise direction. Okay, so now one thing we have to make sure that we are following the window boundary or not. Okay, so now this is the case that we are getting, that is V3 to V4. Okay, and add to the output list and follow the window boundary. Okay, but obviously first of all we have to add the intersection point to the output list, and then we have to follow the window boundary, as you can see over here. Okay, instead of following the polygon boundary. But obviously now for this case you only have to consider, not for the remaining other cases. If it is for this particular line, that is V2 to V4, and if it is getting satisfied that it is going outside from inside, then only you have to follow this thing. Okay, so it will draw this thing, particular thing. Okay, now what? So now again one more thing we are getting is from V4 to V5. Okay, so again the same thing we are getting, that is from outside to inside. Then what it says, we add intersection point as well as the second vertex. Okay, and we have to follow the polygon boundary. So polygon boundary is a fine, we have to just follow the like previous thing that we have seen in that algorithm. Okay, from V4 to V5. My voice would be a bit low, but just bear with me because I have cold. So Try to understand it. Try to understand it. Okay. Yeah. So yeah. So now the next thing that we have, okay, based on the procedure that we are following, so but obviously our intersection point would be named as V5 dash, and similarly V6 dash. Okay, it is going inside from outside, so now we have to add both of this thing and we have to follow the polygon boundary. Now again check this thing, that is v5 to v6. So now second point is getting satisfied, so now we move from v5 to v6 and add intersection point. Okay, just the intersection point will be added and we can name it as v7 dash. Okay, and follow the window boundary because now the second point is getting satisfied. So yeah, so now if this is the case, then again we have to follow the window boundary. So now our window boundary, if I say, that is nothing but our clipping window. So you gotta follow this thing, and yeah, so you gotta follow this thing and it will be giving you something like this. So now this is the shape that we got out of the given algorithm. And similarly, finally, the thing that we need to calculate is for v6 to v1. So but obviously both of these things are outside, so we need not have to add anything into our output list. Okay, so this way we get two separate polygon section after clipping instead of this shape. Because what the earlier algorithm tries to do is, whenever it finds two parallel points, it tries to like join it. Okay, and then it would be giving you something like this. But now we don't want this thing because it is not at all correct. We just want clip part out of the given shape, and this is the correct one. So now this algorithm would be giving us the correct shape after doing all of this step. Okay, so these are the two things that we have for the polygon clipping algorithm. Okay, so these are the two things, and this is the thing. But our last thing that is there in our unit number 3. Okay, and yeah, so that is all in 2D transformation. Okay, yeah. So in this particular like unit, we have seen so many things. Okay, and we have we have gone in a very like proper manner also, so that you get an idea that how these things will work and how you could get some numericals or how you can solve these things. Okay, based on the given algorithm. So that was the thing, and now I will give you two such examples based on the things that we have seen, and you try to solve it and also verify the answer with me. So take out your uh, notebook, pen, and scientific calci also. Okay, so I am switching it. I am writing the numerical on your comment box. Okay. Okay, so here is your numerical. So open your notebook and solve this thing. Okay, and tell me the intersection point that you are getting, and also plot it in your notebook. Okay, P1, or you can say P41 in Q64. Use the clipping, सूत्र coins with a line clipping algorithm. First of all, tell me in which region this endpoints lies. Okay. The next thing that you have to do is to find out the slope. Yes, Jinendra. Okay. Can you tell me the regions? Okay, no problem. 4.67. Yeah, 4.67 and 2. Yeah. What you are doing for Q point, Priyansi? That lies in the window, so you don't have to find the intersection point. Yeah, fine, fine. Then 6 4. Good, good. Yeah, correct. So can you just write the region code for P? 0100, and for Q it is 0000. Okay. Okay, fine. So first of all, in the exam also you have to perform all the steps. That is, you have to perform the end operation and then likewise check the result and then only go ahead. So you just don't assume it from the figure that you draw. Okay, and also plot the figure. Okay, do it. I'm writing the next question. I told you that okay, once you do the numerical, you will find it very easy. So that is what we have in CG. It looks difficult whenever we try to understand it. 14 by 3, comma 2. Yes, it's correct. Writing the second question. Mhm. Correct. 14 by 3 is correct. 14 by 3, comma 2 also. Jinendra. Anyone? First intersection point. You just gotta check it from where it is passing, whether it is from the left boundary or right boundary or top or bottom. The one point is the thing that you easily can get out of it. 2, 2 and 12, 9. 4, 4, 9. Yeah, 2.57 correct, comma 4 and 9619 correct. Yeah. Okay, I'm giving you one more example and then we'll go to the line pass key. Find the pin. X1 X2 minus 1 5 3 8. 34 by 7. Yeah, correct. Correct. Okay, now solve this thing. How all others are doing? Every one of you have to solve this thing, not just sit and like see the answers of others. Yeah, 28 number मोहित क्या कर रहे हो तुम? One number. What is the answer of this question? Number one. Tanis. Okay. Okay, fine. Do it. Okay. Meanwhile, I'm typing that Langbaski numerical also. So that once you finish it, you can -1, 5, and 1/3. This is, yeah, correct. Yeah, correct. Yes, Jinendra. Correct. Hmm. So now I think you are getting this thing. That's okay. बहुत सारा confusion था वो भी शायद clear हो गया होगा आपका. Okay. Okay, two endpoints given to us. It is 3060 in this case and 6025 against the clipping window, but using Langbaski. So, what obviously in Langbaski you have to find few things that is there in your algorithm. Okay, and by that you have to make a decision. So that is P1, P2, P3, P4, P1, Q2, Q3, Q4. 10, 10, 50, 50. Yeah. Hmm. Yeah, 29 number, Rahul. Rahul Meena. Getting getting or not this thing, you're solving this thing. Give me the intersection point. Yeah, phone number say. किसमें डाउट है? लाइन बास की के कोहन में?
सर लाइन बास्की में ही है।
हाँ, व्हाट
अगर
हैपेंड?
यू में न्यू मैक्स से ज्यादा होता है तो फिर मतलब कि लाइन सेगमेंट हम लोग प्लॉट नहीं कर पाएंगे ना।
U1 ना, नहीं तब नॉट तो नहीं होगा, तो you just have to consider this, like calculate this thing, it should be less than U2.
ओके।
हाँ, तो in our case you are getting, what was the value of U1 you are getting?
So in my case, I'm getting UN as
हाँ,
0.67.
0.67.
Uh,
U1, you
yes,
have to
sir.
take maximum out of the given thing, so your P should be less than 0. Okay. So in our case, if you consider this example, we have P1 and P4 where our condition is getting satisfied, it is less than 0. Okay.
Okay.
So you have to consider R1 and R4 in our case. So our R1 value, if I'm not wrong, then it should be like equal to minus 0.667. Yes.
Yes, sir.
And R4 value is
Uh, our
point
value is 0.29
0.29. Yeah. So now what it says is you have to take the max.
max.
Yeah. So now out of both of this thing, what you'd be getting U1 value as.
UN should be 0.29.
Huh, so now your U1 becomes 0.29. Nah.
Yes, sir. Thank you, sir.
Yeah. So now U2 will be 0.667, whatever you have calculated.
Yes, sir. Thank you, sir.
Yeah. Okay, I'm writing U1 and U2 value in the comment box. U1 equal to no money is something you are going in wrong direction. Two, five, seven. See, check for the condition like when your P is getting less than 0. So in our case, our P1 and P4 value is less than 0, if I'm not wrong. And that is the same thing you have to consider in R1, R2, R3, R4. As I said just now, your value will be, you have to consider that you have to consider over here is R1 and R4. So, but obviously now based on the R4, that is the maximum value, as you compare it with the other values that you have, the V1 value will be equal to 0.2857 or 0.29, whatever you are taking. Yes, anyone getting these points? Yes, okay, good. Yeah, most probably I'll be checking your like answer sheets by this Saturday only, and then I will mail you all whatever marks you have scored. क्योंकि टाइम नहीं मिल रहा है and I will try to finish it this week only. फाइनल ईयर का मैंने चेक कर दिया, लेकिन आपका सब्जेक्टिव था तो okay. So yeah, correct. Dinendra. Yeah, it is correct. Okay, so that's it for today. Yeah, you can leave. I'm also leaving. So that's it for today. Next time we'll start with our new topic. Okay, thank you.